Hello, and welcome back. Today, in the fourth lesson of this series, we are going to talk about research and evidence and its role in math modeling. So, why is research such an important part of the math modeling process? So, first of all, researching gives you insights on how you are going to construct your model. Especially in certain cases, you will be given a very domain-specific model, and you might have no idea on how to approach it, and research will help you gain a lot of ideas. And it also makes your model more concrete, because it builds an evidence-based foundation that makes your model makes logical sense. Also, it allows you to find better data for the model, and as we will later see, data is really important in your model. Finally, since the evaluation of a model, in certain ways, is a subjective process, using research and incorporating evidence will make your audience trust your model more, which means they are more likely to like your model and adopt your model. Or in case that you are doing a contest, they might give you a better prize. First of all, citations. So, to show people that 1, you're not plagiarizing, and 2, you used evidence, you should use citations. We need 2 types of citations, which are in-text citations and a reference list at the end of the paper. And in math modeling, particularly, we don't really have a restriction on style. However, it is always a rule of thumb that you must use consistent style, which means you cannot jump from APA to Chicago and Harvard in one paper. However, we do have certain style recommendations. Some of the better ones who do are APA, Chicago, Harvard, IEEE, or if you're using BibTeX, which is a really popular tool, especially if you're writing your paper with LaTeX, you might want to try the UNSRT style or the IEEE TR style. And because you will handle a lot of sources, it is really useful for you to use a reference manager. For example, if you're using LaTeX, maybe you can use BibTeX. Or if you're not using LaTeX and you're just using a conventional document editor, you might want to try EndNote, which is paid, or you can try an open source alternative called Zotero. And they can help you a lot because they help you stay organized, which is extremely important. Now let's talk about the process of researching itself. I would like to clarify to you that throughout your math modeling journey, many of the things you would like to find are not quite easily accessible. And therefore, if you want to find the information you want, you need a proper strategy for researching. So, first of all, you should be absolutely clear with what you're looking for. You cannot just have a blurry idea of what you want, but a concrete item of what you want. Second, you should try a variety of keywords, because in many cases, one keyword will not just directly lead you to your results, so you might want to use a lot of different keywords and also maybe look several pages into each search result. Third, it is often helpful to use academic search engines, especially Google Scholar, because they help you find sources that are more professional and more reliable. And if you have access to databases, it will be extremely helpful if you do research on databases. Finally, you should keep track of anything that is potentially useful, because you might want to go back to it later and actually use it. Finally, it is important to be flexible, because not all of the data is really easy to find. You might need to adopt your model ultimately based on what information you have at your hand. Now let's look at a scenario in which we use research. So that is researching for support. Here we use research to back our assumptions and our models. For example, we can incorporate evidence as justification for our assumptions. One example of this is that when we want to show that an aspect is less significant and therefore we ignore it in our model, we might want to use some data to directly show that it is relatively insignificant. And another way you research for support is to use prior art to strengthen your model, which means you can choose to cite existing models as a foundation of your model. Of course, you do not directly use the existing models. However, using an existing model and modifying it can make people trust your model more. And also, you can cite some conclusions from other models or relevant studies and compare it to your model to show that the results you obtained from your model is reliable. Last but not least, let's move on to the dense part, data. Data is a crucial part of your model, and contrary to popular belief, the data could be just as important as the math in the model. Some of the time, the contest organizer may give you the data. Sometimes you are allowed to make it up by yourself. However, most of the time, you should collect data from research. The process of data collection and the process of model construction should be strongly intertwined, which means that while you construct your model, you should base your model on what data is available, or at least what type of data that would be easy to collect. However, some of the times, your initial idea of the model will require data that you might not be able to find. If you cannot fit data to your model, you should adapt your model, fit your model to the data, because the data is such an important part of your model that you can make changes to the model just to compromise with your data. And that is what I have to share today about researching. Thank you very much.